Hello everyone. Let's wait for 2 more minutes before we start the session. All right. I hope my screen is visible.
Okay, thank you, Dr. Satish. Just give it a
Thumbs up. I'll also allow your mic to be able to interact. Hello, Dr.
Yeah,
Satish.
screen is
Okay.
visible.
Okay. I'm changing the slides and it is working too, right? Can you see me changing my slides?
Yes.
Thank you, Doctor.
Yes.
Okay. Okay, let's start the session. Hello, everyone. I welcome you to the weekly discussion and doubt clearing session number 8 of the NPTEL course Maintenance and Repair of Concrete Structures NOC 23-CE06, which is taken by Professor Radhakrishna G. Pillai of IIT Madras. I am Ashirvad Satpathy. I am a PMRF research scholar at IIT Delhi, and I am also the officially assigned teaching assistant for this NPTEL course. What I do is I usually take these weekly sessions where we discuss the assignment problems that have been given to you in the previous weeks, and also I take the doubts that you might be having regarding the previous week's lectures. There is another officially assigned TA to this course. His name is Umesh. He usually takes his weekly sessions on Fridays from 7 to 9 p.m. And I take my weekly sessions on Saturdays from 6 to 8 p.m. Before we move on to start this session, I also want to mention that I usually record these sessions and I upload it on YouTube. So I have shared the link of the YouTube video of the last weekly discussion session in the meeting chat. You can check it out. And I have also shared the link of the slides that I used to prepare these sessions in the meeting chat also. You can check it out. All right. Um, in this today's session, we'll be discussing the week 7 assignment 7 problems. There are around 8 problems, I guess, and these this week's lectures were more or less related to the uh, various repair strategies and various corrosion protection systems that we can use in order to protect our steel reinforcement in the concrete structures, or we can reduce the probability of corrosion in the concrete structures. Apart from that, we also saw the different placement and formwork strategies that can be adopted at the repair and maintenance sites, so that we can achieve a good repair work, good patchwork, or good repair work that we intend to do at the sites. So these assignment problems are related to those week 7 lectures. And at the end of the session, I'll be taking, if you might be having any doubts related to the week 7 lectures, I'll be taking those doubts. Otherwise, if you have any doubts related to previous week's lectures as well, we can discuss those. All right. The question number 1 of this assignment 7 was, how does the application of anti-corrosive coatings over the steel surface help in corrosion control? The statements were, they enhance the alkaline environment around the steel rebars. The active ingredients such as zinc in such coating materials sacrifice themselves to protect the steel rebars. They isolate electrically the steel rebars from the concrete. The initial oxidation products of the active ingredients is zinc oxide in the coating material form a barrier over the steel substrate. Which of these options are correct regarding the anti-corrosive coatings over the steel surface? Can somebody answer to this question? I've allowed your mics. Let's keep this session interactive. Yes. Yes, Dr. Satish, you can go ahead.
If no other participant is willing to answer, I would like. All
Yeah,
the
yeah, sure.
four options are correct because they enhance the alkaline environment. The ingredients such as zinc in such coating material sacrifice, yes, this is sacrificial in nature. Third one is they isolate electrically the steel rebar from the concrete. Yes, the initial oxidation products in the coating material form a barrier. All the four options appear to be correct.
Okay, you may think that all the four options are correct.
Yeah.
Okay. Actually, only the second, third, and fourth are correct. I'll discuss
Oh,
why. Um, because the first option, it says that they enhance the alkaline environment around the steel rebars. But the anti-corrosive coatings, thank you, Dr. Satish, for first of all for
yeah.
answering the question. Yeah, I'll be discussing these statements again. Yeah. So these anti-corrosive coatings, as it is mentioned in the other statements as well, they contain some kind of a sacrificial anodic material or a metal that will act as a sacrificial anode in these systems. So these anti-corrosive coatings, let's say they contain zinc, and that zinc gets corroded while it protects the steel reinforcement, as we have seen in the case of galvanic corrosion. So when these anti-corrosive coatings are applied on the steel reinforcement surface, they do not enhance the environment, electrochemical environment around the steel reinforcement as such. But what they do is they get corroded, and these corrosion products that form over the steel reinforcement, they in turn protect the steel reinforcement from any attack by the chloride ions, or let's say due to the decrease in pH or any other corrosive process that might occur inside the concrete structure that won't affect the steel reinforcement, because there is a additional initial oxidation products that is mentioned in the last statement. The initial oxidation products of the active ingredients like the zinc oxide form a coating around the steel substrate, steel reinforcement that is already present inside the concrete structures, and that in turn protects the steel. Yes, they isolate the steel rebars from the concrete. So therefore, a decrease in the pH or due to the presence of chloride ions in the concrete, it won't affect the steel rebars as soon as it will affect in a system which doesn't have an anti-corrosive coating on the steel rebars, because due to the application of this anti-corrosive coatings, they isolate the electrochemical environment of the steel reinforcement surrounding the reinforcement from the concrete core that is present outside or far from the steel reinforcement. So these anti-corrosive coatings, they isolate the steel rebars from the concrete electrically. And the second statement was the active ingredients such as zinc in such coatings materials sacrifice themselves to protect the steel rebars, as we have discussed. Yes, this is also true. The anti-corrosive coatings are essentially galvanic anode protection systems. So they're just a layer of some corrosive, some material that will get sacrificed as an anode while protecting the steel reinforcement, which will act as a cathode in this. But they don't enhance the alkaline environment. They won't, like we have studied in the case of realkalization, electrochemical realkalization process, or in other processes as well, when there is deposition of hydroxyl ions around the steel reinforcement, and thereby it regains the passivating film around the steel reinforcement. That won't occur in the case of anti-corrosive coatings. So these three are the correct options. All right.
Uh,
Moving on to the second.
I,
Yes, yes,
uh,
doctor.
uh, Mr. Satpathy, they released the answers on 15th.
Okay.
They say first one is also correct. Probably they mean, pH comes down due to corrosion, etc. When you remove the products and apply some coating, probably pH is improved. They have shown this also as the correct answer.
Okay, this has been also shown as the correct answer.
Yes, yes,
Um, okay. I'll check it again.
yeah.
Okay. Yeah, I'll check it again and let you know in the next session then. Okay. Thank you, doctor. Okay, moving on to the second question. Um, Select the key features that a good galvanic anode system should have to ensure long-term performance when used in concrete structures. And which of these key features would you want? Encapsulating mortar with neutral pH to ensure that the zinc anode will continue to corrode. High alkaline, say pH greater than 13.1 or so, encapsulating mortar to ensure that the zinc-rich anode will continue to corrode and protect the steel. Encapsulating mortar with disconnected pores to prevent the migration of the corrosion products. Large surface area of the anode metal to be able to meet the high current demand. Anode tie wires should be welded to the anode metal surface. Anode tie wires should be die cast into the bulk of the anode metal. Which of these key features should be present in a good galvanic anode system? Can somebody answer this question?
Mr. Abhay, Rishikesh, Arkarai, they are also around. If they want to answer, it's
Yes.
better.
Anybody else wants to try? Orko, Abhay, I see Rishikesh is on hold. Orko and Abhay, if you want to try, go ahead.
Yes, sir.
Yes, Orko.
Sir, actually, the answer to this question would be that zinc will corrode in a very alkaline environment. So
Okay.
the second option,
Okay.
then the large surface area of the metal will also be able to deliver more electrons to this
Right.
rebar system. So it will help in meeting the high current demands,
Right.
and the anode tie should be die cast because it will give more surface area of the tie to get the electrons from the zinc.
Okay.
Welded things may get loose from the surface of zinc. So I think these three are the correct options.
Okay. Okay. Thank you, Orko. Yes, you're right. Rightly mentioned. We'll be discussing all the statements one by one. Encapsulating mortar with neutral pH. So the first drawback in this statement is the neutral pH. We know that for zinc to corrode, it requires a pH that is higher than 13 or so, and therefore a neutral pH means pH around 7. won't work for zinc anode because zinc won't be able to corrode at such a low pH, that is a neutral pH, and therefore this is not what we want in a good galvanic anode system. The second option is true because a high alkaline pH, so the encapsulating motor around the zinc anode, basically, if you have seen in the lectures as well, let's say this is the zinc anode. So there is another encapsulating motor, and this is an active or activated cementitious motor. This is the anode. Cementitious motor, and it has wires coming out of it for the connection, right? And so the active cementitious motor is required because while the cementitious reactions or the cement hydration reactions are going on and actively the hydration products are getting formed, the pH of the system will remain high, and that will be conducive for the zinc anode to get corroded, so that it will act as an anode and protect the steel reinforcement that is inside the concrete structure, which will act as a cathode in this system. So this is the correct option. The third statement was encapsulating motors with disconnected cores to prevent the migration of corrosion products. Uh, the if there are cores sufficiently available inside the cementitious mortar, then when the corrosion products are formed at the anode location, they'll be having sufficient space for it to expand, and therefore um, we need the pores inside the active cementitious motor as well. But this is not the correct option because um, what it says is encapsulating motor with disconnected pores to prevent the migration of corrosion products. We in fact want the migration of the corrosion products because this is not indirectly, the corrosion products cannot directly migrate into the concrete through the concrete to the steel rebar location, and therefore if the pores are connected and if there is sufficient amount of pores available, then they can these corrosion products can precipitate within the pores, and if they're connected, then these corrosion products can travel outside and form over the surface of these anode cementitious motor system without getting formed inside the cementitious motor system. So that will prevent the cracking of this cementitious motors and zinc anode system. So this is not the correct option. The fourth statement was large surface area of the anode metal to be able to meet the high current demand. Yes, this is also true, as Orko has already mentioned. That we know that, see, this is the relation. V by R is directly proportional to the current. V is the voltage, R is the resistance, and R we know is rho L by A. L is the length of the resistor, and A is the area, right? And so this gives us V A by rho L, right? Is directly proportional to I. So if it has a large area, then the current will be larger, and therefore we'll be able to extract more current whenever there is a high current demand. We'll be able to extract more current, and therefore will be reducing the number. This will result in reducing the number of the anode galvanic anode systems that are being placed in the concrete structures. Because see, in this galvanic anode system, unlike the impressed current cathode protection system, we can't control the amount of current that we can draw from the system, this galvanic anode system, because this is directly in contact with the steel reinforcement, and there is no external voltage applied in order to control the current. So therefore, if we want a higher amount of current to flow, then we have to place a large number of galvanic anode system, or else what we can do is that we can have the galvanic anode systems that have a larger area, so that we reduce the number of these anode systems that we have to place in order to meet the same current demand. So this is again true. Large surface area of the anode metal will be able to meet the high current demand. Anode strive wires should be welded to the anode metal surface. This is wrong because in order to weld the metal surface, you'll be using probably another metal, and that will change the electrochemical environment around the system, and that might affect with the zinc anode getting corroded due to the welding process. Therefore, these anode tie wires should be die cast into the bulk of the anode metal, while these and the these and wires, tie wires, are emerging from the anode. It has to be the cementitious mortar has to be cast around this system, so that without any welding of the tie wires. So this is a correct option again, the last option. So yes, these three are the correct options, as Arthur has already mentioned. All right. Moving on to the third question. As per the lecture, which method of electrochemical repair would you suggest to extend the service life of a severely corroding bridge for another 25 years without any intervention? Without any intervention for 25 years, and the bridge is severely corroding. Bridge is located in a remote area causing difficulties for frequent inspections and maintenance. Select the most feasible method. Alkaline slurry coating over the concrete surface, impressed current cathodic protection, galvanic anode cathodic protection. Which of these protection systems would you like to implement in such a severely corroding bridge, which we require to have another 25 years of we need to prolong the service life of the bridge by another 25 years without any intervention, and the bridge is located in such an area that there is difficulty in frequent inspections and maintenance. Can somebody answer to this question?
I would like to answer this question.
Yes, Doctor.
Alkaline slurry may not last for 25 years. The situation is that of a severely corroding bridge, so this may not be the best option. Impressed current cathodic protection requires continuous monitoring.
Right.
So the problem says that monitoring is difficult.
Right.
Last one, sacrificial anode system using zinc, that is the best option. Once you install it and forget about it.
Right.
So you have to design it properly. It can continue for 25 years without any intervention in between.
Yeah. Thank you, Dr. Suresh. Yes, you have rightly mentioned. First of all, the first option is the alkaline slurry coating over the concrete surface, and the first fault in this option is over the concrete surface. The alkaline slurry coating, whenever it is done, it is generally done over the rebars after removal of the concrete from that area, because we want the environment around the rebars to be alkaline in nature, not the surface of the concrete. The providing an alkaline surface coating on the concrete won't help anything, because that won't protect this rebar from getting corroded. That won't provide alkaline environment around the rebar. So this alkaline slurry coating is done on the rebars and not the concrete surface. Whenever there is any kind of anti-corrosive coating that is being applied on the concrete surface, let's say it has some zinc compounds or any sacrificial metal compounds in it, it has to be connected to the rebar for it to act as an anode. So you have to have a connection between the concrete surface, the coating that is applied on the concrete surface, with that of the rebar. So just applying another coating on the concrete surface won't prevent the corrosion at the rebar location. So this is not the correct option. And again, as Dr. Satish has already mentioned, even if you apply the alkaline slurry coating on the rebar surface, these are not very effective systems, and they won't last for such a long period. They can only provide us a protection against the corrosion for probably 5 to 6 years. So yeah, so this is not the option for this particular case. We should not go with this option. The second option was The second option was impressed current cathodic protection, or ICCP. And as Dr. Satish has already mentioned, and also we have seen in the lectures as well, impressed current cathodic protection is requires an external voltage to be applied to the anode, to the, let's say, the titanium mesh that is being provided inside the concrete, to draw the electrons from the titanium mesh, and thereby making it to corrode or to get oxidized, while providing a reducing environment at the steel rebar location. And since the amount of current that is to be drawn from that is to be drawn, I mean, so the amount of electrons that is required to be drawn from the titanium mesh is needs to be varied according to the requirement of the, or the current demand in the steel concrete system. This requires a lot of maintenance, this requires a lot of monitoring, and this requires a lot of inspection to maintain the current that is being applied, that is being drawn, the current demand that is being that is required. It has to be met by drawing the electrons from the titanium mesh, and therefore a lot of monitoring is required, and all the time you have to maintain the voltage so that the current demand that is being generated is being met. So, due to the continuous requirement of monitoring and inspection, this should not be, again, this is a very good system to go with, but this should not be opted for in this particular case, because the bridge is located in a remote area, and it is difficult to go there for inspection and maintenance, and therefore we have to go with the galvanic anode cathodic protection system. What we can do is we can calculate the number of anodes that is required, and the shape and size of the anodes that is required for achieving this service life of another 25 years, and we can install these galvanic anode systems in the concrete structures, so that will, and we can just install it and forget about it, because there is no external circuit required, because the circuit itself is formed between the anode and the galvanic anode and the steel rebar, which is acts as the cathode, and therefore the battery itself is created without the application of any external voltage, and therefore no maintenance or inspection is required. So this is therefore the correct option. Galvanic anode. All right. Moving on to the fourth question. What properties are essential for an anode metal to be used in an impressed current cathodic protection system? Which of these properties are important? More electronegative compared to the metal, say steel, being protected, highly corrosive, highly conductive, electrocatalytic. Which of these properties need to be present in the anode metal of the ICCP system? Yes, can somebody answer?
Sir,
Yes, or
sir, the first option, that more electronegative, if the anode is more electronegative compared to metal, it will tend to draw electrons from the system towards itself, so it won't be the right one.
right,
Then it should not be, the anode should not be highly corrosive, then it won't be able to meet the demand of electrons to the system which we are intending to protect.
right.
The anode should be highly conductive and
Mhm.
electrocatalytic.
Right. Thank you. Very good, doctor. Thank you. Yes,
Thank you.
these two are the correct options actually. Yes, if it is this, the anode is more electronegative. So more electronegative, which that it will have an affinity of accepting electrons or drawing electrons from the system, as Orca has mentioned. So we want if the anode metal draws the electron from the system, then that will get reduced. So that will become the cathode, while the anode, the steel reinforcement that is on the other side, will become the anode and it will get corroded. So it will be of no use. Therefore, we want the anode metal to be more electropositive so that it will have the tendency of losing electrons, so that we'll be able to easily draw electrons from the metal. So losing electrons means oxidation, so that anode metal will act as an oxidation site and therefore it will get corroded, while the cathode, the steel reinforcement, will act as a reduction site and therefore it will become the cathode and it will get protected. So therefore anode metal needs to be more electropositive in nature, right? So this is the wrong statement. Again, highly corrosive. If you have a highly corrosive metal, let's say, why do we use titanium instead of zinc? We can also use zinc, or we can in fact use another steel mesh. But the problem with that is that if we use such a highly corrosive system, it will get consumed within a few, let's say, few months or few years. So we don't want that. What we want is the metal should be highly corrosion resistant, so that even though we'll be requiring a higher amount of higher voltage to draw electrons from it, but it will stay that we won't be we won't need to replenish the metal as frequently as it will be needed in another metal which is highly corrosive in nature. So because these metal mesh, the anode metal is embedded within the concrete structure, within the concrete, and there is a concrete overlay thickness, as we have also seen in the lecture as well. So let's say this is the system. I'm trying to draw it here. All right, and this is the reinforcement, and there is this mesh that is running, that is being provided, and again on the top of it, there is a concrete overlay. This is the concrete overlay. This is the titanium anode mesh, and this is the steel rebar. All right, and this is connected to the positive terminal, and this is connected to the negative terminal. So this draws the electrons, and so this act as the cathodic site, and this act as the anodic site. So since there is a concrete overlay on the top of the titanium mesh, and it will be difficult to replenish or replace that mesh as frequently. Therefore, we want a low or a high corrosion resistant metal to be used as the anode metal, so that it even though we'll be requiring a higher voltage to be applied, the voltage applied will be very high as compared to if we used a steel reinforcement as a anodic metal, but will not be required to replace the mesh as frequently as it will be needed in another type of metal, which is highly corrosive. Therefore, we want the metal, that anode metal, to be low corrosion, less prone to corrosion, or high corrosion resistant. So this is a wrong statement. Yes, it has to be highly conductive so that it will be able to lose electrons. So this is a true statement, and it has to be electrocatalytic so that it will be able to take part in the anodic reactions and therefore it will protect the steel reinforcement by getting sacrificed at the anode location. So these two are the correct options. All right. Okay. Moving on to the fifth question. The fifth question was typically calcium hydroxide solution is used as the electrolyte for electrochemical chloride extraction process, ECE. Why? Why calcium hydroxide solution is used? And the options were: it prevents the chance of acidification of the electrolyte, embedding the anode material during the high current applied. It prevents the etching of concrete. It helps to restore the passivity at the steel concrete interface. Which of these options are correct? Dr. Satish, have you raised your hand?
Yeah.
Yeah, yes, go ahead.
Uh, the first option is correct because acidification of electrolyte is a common problem in this type of situation.
Right.
So since this material is alkaline in nature, therefore it will prevent acidification of electrolyte. Then
Right.
it prevents the etching of concrete, which is a common problem when we do extraction, when we use this extraction system. Then since this is alkaline in nature, it restores the passivity also because of
Restores the
alkalinity.
passivity at the steel concrete interface.
Interface. Yes, yes. Because
Okay.
calcium hydroxide is alkaline in nature, pH value is quite high, so it restores the passivity.
Okay. But using the calcium hydroxide solution will restore the passivity at the steel concrete interface. How?
Yes,
I guess you're
yes.
referring to the this is in the case of electrochemical realkalization.
But here also you are using calcium hydroxide solution.
Yes.
So third one is also correct.
Okay. The calcium hydroxide solution is actually used to draw the in the process in the case of electrochemical chloride extraction. What they usually do is they intend to um, extract the chloride, the ions that are present inside the concrete surface, right? And therefore they apply a positive voltage and an anode metal, and there is an electrolyte present, so that these chloride ions get attracted towards the positive terminal and travel through the pores that are saturated and get out and into the electrolyte. And in that region, the anode gets corroded while there is a cathodic process going on at the steel rebar location. But using the calcium hydroxide solution has no direct relation with restoring the passivity at the steel concrete reinforcement, steel concrete interface. So I guess only these two options are correct, as you have mentioned. Thank you, Dr. Satish, for answering. Uh,
But they released the solution on 15th. They
okay,
say last option is also correct.
is it?
Yes, yes.
Um, I might be having the answers. Let me check. Just give me a moment.
Yeah, yeah. Kindly, please, please.
I guess, Dr. Satish, I have checked it again. You also mentioned about the question number one, right? They enhance the alkaline environment around the steel rebars. I don't think that is the correct answer. They have not mentioned that in the accepted answers. Also,
Okay,
in this question, they haven't accepted it restores the passivity at the steel concrete reinforcement as the correct answer. It is not.
okay.
Because I'll tell you why. Because even if you use another electrolyte, The restoration of the passivity at the steel concrete reinforcement is essentially due to the cathode that is getting cathodic reaction that is taking place at the steel rebar location. So it has nothing to do with the type of electrolyte that you're choosing. The electrolyte that you're choosing will affect the electrochemical extraction of the chloride. That is the essential goal of this process. So anyway, whatever electrolyte you use, since there is another anode present at the top, or which is connected to the positive terminal, therefore the steel rebar will always be the cathode, and therefore the hydroxyl ions will get accumulated around the steel rebar, and therefore the passivity of the steel reinforcement will be restored. It will be irrespective, or it won't depend on the type of electrolyte what is being applied in this process. What will be affected is the chance of acidification, because using another since calcium hydroxide solution, generally a saturated calcium hydroxide solution is used, and it has a very high pH. Therefore it will reduce the chance of acidification of the electrolyte, because since it is a solution and chloride ions are getting extracted from the concrete, therefore these chloride ions might get into the will go into the electrolyte eventually, and they might uh, react and form hydrochloric acid or HCl, right? And that will cause the acidification of the electrolyte. But if a calcium hydroxide solution is used as the electrolyte, then a calcium chloride will be formed, and therefore the acidification of the electrolyte will be prevented. So this is this is a true statement. It prevents the chance of acidification of the electrolyte embedding the anode metals, because the anode metal is present in the electrolyte. It is dipped in the electrolyte during this process. I'll draw the typical arrangement of this process. So this is a voltage applied, and this is a concrete block, and it has a rebar at this location. And this is connected to the, and there's a anode mesh that is present over the top. The typical schematic arrangement of this ECE process, electrochemical extraction of chlorides. This is the anode mesh that is present at the top, and this is connected to the positive terminal of the anode, of the battery, the external battery, and there is a this is inside a container probably, which contains the electrolyte. Electrolyte, right? This is the mesh, metallic mesh, anode. This is the steel rebar.
This chemical formula for calcium hydroxide will be CaOH twice, because
Right,
calcium has
right.
two
Thank you.
positive valence.
This is the concrete, right? This is a typical schematic arrangement of the electrochemical. So this concrete, this is a concrete. This has a number of chloride ions, and due to the application of a positive uh, uh, voltage at this location, positive potential at this location, these chloride ions get drawn into the electrolyte solution, and this anode, while this anode gets corroded, and this is the steel rebar, which is the cathode, and hydroxyl ions get accumulated around the steel rebar, and therefore the passivity of the steel rebar is reinforced. But that will be respective the type of the electrolyte that is used. Okay. And the second statement was it prevents the etching of concrete. Yes, that is again true, because if the electrolyte is acidic in nature, that might etch the concrete. Also, we have also seen in the lecture using a titanium mesh can probably cause some kind of etching of the concrete surface. And however, using a calcium hydroxide solution as the electrolyte, which will reduce the etching of the concrete or prevent the etching process in the concrete. So therefore, this is again a true statement. There are two answers to this question. All right. Okay, moving on to the sixth question, and it's a very good question. It will also revise some of the concepts that we have discussed in the previous week's sessions. Okay, the question was rust stains have been observed on the concrete girders of an overpass located above a traffic signal in a tropical urban city. Laboratory test results conducted on concrete samples collected from the girder are given below. The chloride content is 0.01% by weight of the concrete. Carbonation depth is greater than cover depth. The carbonation depth is greater than correct cover depth. Oxygen permeability index is 9.1. When a 4 probes surface resistivity is 30 kilo, I mean, this result gives us 30 kilo ohm centimeter. The resistivity has been found as 30 kilo ohm centimeter, surface resistivity. And the question asks, which among the following is the most effective repair strategy to extend the residual service life of the bridge? The options given were surface cleaning and anti-carbonation coating, anti-carbonation coating followed by electrochemical chloride extraction, cement-based coating and anti-carbonation coating over the girders, electrochemical realkalization followed by anti-carbonation coating. Which of these options are correct and why? Can somebody answer this question? Yes, Dr. Nitish. Right.
You see, in the problem, chloride level told is only 0.01% by weight of concrete. This is a low level.
Right.
So chloride attack is not the major problem. Carbonation depth more than cover. So it's a case of carbonation. Then OPI of the order of 9.1 is related to poor quality of concrete, poor concrete. And then resistivity level 30 kilo ohm centimeter is again a low level. This relates to poor concrete. So this is a case of poor concrete and a case of carbonation and not a case of heavy chloride intrusion. So the best option will be you need to re-alkalinize. So and then anti-carbonation coating is also required.
Right. Thank you, Dr. Sidhu. You have rightly explained.
Yeah, yeah.
Yes, as he has already mentioned, first of all, the chloride content. Let's see what is the condition, the exposure condition of this bridge. It is present in a tropical urban city, and it is over a traffic signal. So it is not exposed to any coastal environment or which an environment which might be rich in chlorides. So based on the location, also we can assume that uh, there won't be sufficient amount of chloride available in the environment or any kind of exposure that will cause a chloride induced corrosion unless there is a admixed chloride in the concrete, like admixed chloride as in if the chloride is already present in the mixing water that is being used while preparation of the concrete or manufacturing of the concrete, right? So based on the exposure condition and the location of this bridge, we know that it is away from the coastal environment, and therefore it is not exposed to a chloride-rich environment. But again, we did the chloride content test, and we found that the chloride content is low. Therefore, there is no admixed, so there is the less possibility of admixed chlorides um, uh, in the water, and the amount of chloride already present in the concrete is sufficiently low, therefore below the chloride threshold, and therefore the chances of chloride-induced corrosion is low. Second, we found the carbonation depth is greater than the cover depth. That means that the carbonation front has passed the cover depth and is at the rebar location now. So that much depth of the concrete has already gotten carbonated, and therefore this is a case of carbonation, as Dr. Satish has rightly mentioned. Right. Apart from that, we did the oxygen permeability test, and we saw that the OPI is 9.1, and we know that an OPI value greater than 10 is a sign of a good concrete. Good concrete as in has a less permeability to gases. So a low OPI index, OPI value means that the concrete is highly porous, it has high amount of connected pores, and the permeability of the concrete is high, right? And that is not a good sign because, and it is also obvious because the concrete has gotten carbonated. Therefore, already carbon dioxide has been able to get inside the concrete, and therefore the pore size have enlarged because of the carbonation process, and therefore there is a high permeability in the concrete. The fourth test that we did was the surface resistivity test, and we saw that the surface resistivity is very low, 30 kilo ohm centimeter only, and we know that for the Venner 4-probe surface resistivity test, resistivity greater than 100 kilo ohm centimeter is a sign of a good concrete. I'll just remove this to avoid confusion. Yes, so this is required for a good concrete, right? Surface resistivity of greater than 100 kilo ohm centimeter, and we see that it is only 30. So the surface resistivity test also indicates that the resistivity of the system is poor. It is highly conductive. It has highly permeable pores, and the pore connectivity might also be high, and therefore, as Dr. Satish has also mentioned, this is a pure case of carbonation and a poor quality of concrete, and the chances of chloride induced corrosion is very low, right? Therefore, we have to choose the effective repair strategy. And what should be done? Surface cleaning and anti-carbonation coating. Only cleaning the surface won't help because the carbonation front has already surpassed the cover depth, and it is at the rebar location now. So just anti-carbonation coating won't help because already the pH around the steel rebar is sufficiently low because the carbonation has already occurred. The reserved alkalinity present around the rebar in the location around the rebar is has been consumed by the carbonation process, and therefore the pH has gone down, and now the passivating film probably has been affected, and therefore the steel is more prone to corrosion now. So surface cleaning and only anti-carbonation coating won't work. We have to enhance, since the carbonation front has already reached the steel rebar location, we have to enhance the pH around that steel rebar location. The second statement is anti-carbonation coating followed by electrochemical chloride extraction, and we see that already the chloride content that is present within the concrete is sufficiently low. So this is not a case of chloride induced corrosion, and therefore applying or implementing a electrochemical chloride extraction process is only a waste of money and time, and it won't help increase the pH of the concrete. I mean, it might help in restoring the passivity of the rebar location, but this is not the best or the most effective method to go with, because this is not a case of chloride induced corrosion. The amount of chloride that we will be able to draw will be very less. Therefore, this is not the right way to go with. The third option is cement based coating and anti-carbonation coating over the girders. Again, as we have already discussed in the first option as well, the carbonation front has already reached the rebar location. Applying a cement based coating now won't help, because already the concrete is carbonated, and therefore this is not the right answer to go with. And the fourth option is electrochemical realkalization, followed by anti-carbonation coating. Yes, first we need to realkalize the concrete. The pH must have gone down, and therefore we have to apply. We have to implement this technique, the ERA technique, for the pH to be enhanced inside the concrete, so that the concrete will have a conducive environment for the steel reinforcement. The pH will be high, therefore the passivity around the passivating film around the steel reinforcement will be restored, and therefore it will prevent the steel from getting corroded. After that, we can apply the anti-carbonation coating. And in this electrochemical realkalization process, what essentially is done, it is again very similar to that of the electrochemical chloride extraction process. So I'll draw the same diagram again. Only it is a change of the electrolyte. That's all. This is a steel reinforcement. And this is the electrolyte, and there's a anode mesh. This is anode mesh, and this contains the electrolyte. Typically, the electrolyte that is used is a combined solution of Na2CO3 plus Na2CO3 is sodium carbonate, and NaHCO3 is sodium bicarbonate. This is the solution that is generally used, and this, what it does is that uh, this alkali solution gets inside the concrete, and that will at this location, at the rebar location, which is the cathode location, hydroxyl ions are getting accumulated. That will restore the passivating film, and this will realkalize the concrete. The alkali solution will realkalize the concrete, and within a few months or days or years, depending on the concentration and the voltage applied, within a certain duration, we'll see that the concrete starts to realkalize. It starts to gain the pH. So this is the ERA technique, right? So electrochemical realkalization is required wherever there is a sufficient carbonation has occurred and the reinforcement has already started to corrode. The carbonation front has already surpassed the cover depth. We have to go for realkalization only. That is the only option. Followed by anti-carbonation coating, because after you have done the realkalization, you have restored the pH of the concrete. Now, if you apply anti-carbonation coating over the surface of the concrete, that will prevent from further carbonation from occurring, right? So that will again protect the steel reinforcement, and this electrochemical realkalization process, the service life of that repair work will be enhanced due to the application of the anti-carbonation coating, because it will prevent the carbon dioxide from getting inside the concrete. So this is the right answer, right? I hope this is clear. This is a very good question. The seventh question was, choose the correct statements regarding the grouted pre-placed aggregate method for placing concrete. The options are: well-graded aggregates are used to achieve a high particle packing and strength for concrete. Gap-graded aggregates are used to enable the filling up of the voids by high-pressure grouting. This method is suitable where extremely low shrinkage of repair material is expected. This method is suitable where reinforcement are congested. Which of these options are correct?
Sir,
Yes, also.
actually, sir, well-graded aggregate system means that there will be high particle packing, so the grout material can't flow and fill up the voids because it is already occupied by the aggregates.
Right.
It is this system, so this can't be true. Gap graded system is can be used for this because there will be voids in which through which the grouted material can pass. Actually, the grouted material is poured from the bottom to the top, so that it can occupy within every space of the
Right.
concrete.
Right.
So the second option is correct,
Okay.
and this method is suitable where extremely, yeah, the third option is also correct
Okay.
because this is because that if the repair material is more has low shrinkage, then only we can apply this method. Otherwise, the grouted material will get loosed
Okay.
due to shrinkage.
Okay. Okay.
And
And the
the
fourth
last
option.
option, and I don't think the last option is correct because reinforcement is congested everywhere. That does not mean that the grouted material can't flow through it.
Okay. Okay. Thank you. Thank you, Arka. Yes. Let's go. Uh, let's discuss all the statements one by one. The first statement is well-graded aggregates are used to achieve a high particle packing. Well-graded aggregates will give you a high particle packing, but the problem with this method is that we have to pump the grout into that material, into the structural element through a very small sized hole, and therefore we won't be. So essentially, if we had been pumping the concrete instead of the grout alone, then we would be going with the well-graded aggregates because well-graded aggregates will enhance the particle packing of the concrete, and therefore that repair work will be achieving the goal that is expected out of it. But what we are doing is we are only pumping the grout, and we're expecting the concrete to be formed within the formwork inside the structural element. So what we need to do is we have to place gap graded aggregates inside the formwork at the structural element location. And now we are pumping the grout. The grout is essentially the cement slurry or the mortar slurry. So that grout will fill up the voids within the gap graded aggregate. So essentially, what is done is that the grout should have the size of the particles which will be able to fill the gaps that is present within the aggregates that is already placed in the structural element or within the formwork. So therefore, gap graded aggregates are first placed in that formwork, and then grout is pumped so that it will work. It will become a concrete after it gets pumped and fills the voids within the gap graded aggregates. So the second option is therefore true. High pressure grouting is used to fill up the voids between the gap graded aggregates, right? The third statement says this method is suitable where extremely low shrinkage repair is expected. Yes, again true, because there's a high amount of high volume of aggregates that is being used in this repair. Already the graded aggregates are present, and therefore uh, whenever we are using a concrete or repair material that has a large volume of aggregates in it and less paste volume, that will limit the shrinkage because shrinkage is caused by the presence of the cement paste. The cement paste is the constituent of the concrete that gets shrinked, that shrinks, right? So uh, therefore, due to the presence of these aggregates and a large volume of aggregates, the shrinkage in this kind of repair will be less, and therefore this method can be used where low shrinkage is expected. So this is again a true option. The last option is this method is suitable where reinforcement are congested. No, because we have to place the gap graded aggregates. So for the gap graded aggregates should, of course, should be such that they should be less than the size of the gaps between the reinforcement. The aggregate size will be less than the gap between the reinforcement. But since we are placing it initially, therefore, having a good, having a high amount of congestion of the reinforcement will hinder the placement of these gap graded aggregates, and therefore this method will not be suitable for a location where there is a congestion of the reinforcement. Also, a congestion of the reinforcement will prevent the grout from filling up all the void locations and covering all the regions in the inside the formwork. Therefore, this method, and since it is pumped with a high pressure, and this is generally typically done on vertical elements and not horizontal surfaces, this is generally done on vertical elements, and therefore having a reinforcement congestion will prevent the grout from filling up all the void location, and therefore this is not a suitable method for case where there's a congestion of reinforcement. So only two of these options are correct. The presence of gap graded aggregates are used initially, and then the grout is pressure pumped into the formwork. And the second is this is done where a low shrinkage is required. Right. Moving on to the eighth or the last question. In shotcrete, the addition of viscosity modifying admixtures or VMAs help in reducing the rebound of the mix during the application. Is it a true or a false statement, and why?
Sir, actually it's true,
Okay.
because in shotcrete
Mhm.
we are pumping the motor through a nozzle, and in the nozzle we are applying viscosity and modified admixture, so that it makes the concrete more, it makes the plaster more viscous, so that it does not get off when it's stuck on the wall
Right.
during application.
Right. Thank you. Thank you, Arthur. Yes, you've very rightly answered this question. So viscosity modifying admixtures generally are used for those kind of applications where after the concrete or the cementitious suspension is poured, we want the viscosity to be increased so that it won't fall off, or it won't flow out of the surface. Let's say this is done essentially in the case of shotcreting process, because the viscosity modifying admixture increases the viscosity of the concrete or the cementitious cement based suspension, and after we have shot the concrete onto the surface, onto the vertical surface, or onto the surface of a tunnel, or let's say wherever the shotcreting application is taking place, the viscosity will be increased. Therefore, the rebound is the falling off and loss of material during application. Right? So, if the viscosity is enhanced, then the material will be having a high viscosity, and therefore it won't fall off. It will have a higher cohesion between the layers, and it will stick onto the surface and won't fall off. Therefore, the rebound and the loss of the material will be reduced. This is also done in the case of 3D printing as well. So 3D printing as applications are generally require that we place the concrete layer by layer on top of each other, and therefore uh, but it has to be placed, or it has to be poured through a nozzle. So we want the material to have a low viscosity while it is being pumped, so that we will require less pumping energy. But after it has been placed as a layer over the perimeter that is being designed, we want the viscosity and the yield stress to be high, so that the layer will not fall off, will not flow, and it will have its buildability, or it will have its shape intact. So this is also used. The VMAs are also used in those applications as well, where we want to enhance the viscosity after we have placed the concrete in its particular location. So this is a true statement, right? This ends the assignment questions of week 7. If you have any doubts, you can ask the questions. We can discuss them. Otherwise, you can leave.
Sir,
Yes.
Sir,
Okay.
I have a question. It
Yes.
is regarding the last week's assignment that
Okay.
of week 8.
Okay.
That of week 8. Sir, are you in the
Week
doubt
8,
discussion forum? Yes, sir.
has it been submitted yet?
Yes,
I
sir. It
mean, the
has been
deadline.
submitted.
This
Yeah,
when
yeah,
is the
sir.
deadline?
It's the deadline was on 22nd
Okay.
of this
Okay. I
month.
have not actually gone through the assignment questions. Okay, you can ask the question. What is it?
Sir, are you in the doubt discussion forum?
No, actually, my work is limited to taking these weekly sessions only. So,
Okay, sir.
yeah.
Then can you please let me share my screen? I want to show the email which I have sent to the panel.
Okay. Has anybody answered to your query?
Yes, sir. Someone in the named Umesh
Yeah, Umesh.
Hule has, yeah, he has answered my
He,
question, but I'm not getting it clear. So there was a question. I'm telling the question. Um, just a
you
second.
can
I'm
share your
opening.
screen. Did I allow you? Do you want? Do you need to share your screen to ask the question?
Sir, first I am telling the question. If it's necessary, then you can allow me. Then I'll share my screen
Yeah.
also.
Go ahead.
Sir, the question is that, just a second,
Yeah, take your time.
sir. Which among the question stated, it was the question 8 of assignment. It was the question 5 of assignment 8. Which
Mhm.
among the following can be given the least consideration while selecting a waterproofing membrane?
Okay.
And the options that were given were elongation and tear resistance, then surface finish, then compatibility and bond of the membrane with the concrete substrate,
Mhm.
compressive strength, and overlapping and gluing of the membranes.
Okay. And the question was which of these options?
Which among the following can be given the least consideration while selecting a waterproofing membrane?
Okay. Yeah. What is it about?
So actually I answered the option that overlapping and gluing of the membranes, because I think this is a constructional procedure. It is a workman practice. I know that if I overlap and glue the materials, then it will be impermeable and make the membrane more porous, so that it can serve the procedure.
But you want to choose the option that is least, it has to be given the
The-
least consideration, right?
yes,
What
sir.
you are saying is
The other,
uh, that will prevent, I mean, that will give a impermeable nature to the concrete. So that is required
yes,
in a
sir.
waterproofing process, right?
Yes, sir. Sir, let me say the options, the other options which were given, they are more
Why,
specific on the
why,
material
why,
property.
why do you want a high compressive strength in a waterproofing membrane? What is the
So,
role of having a high compressive strength of the waterproofing membrane?
sir, if I applied some load on the
Mhm.
I want to suppose I want to make a roof impermeable. If I keep something on the roof, if the material is not compressive, then it will get teared.
How does applying a compressive load tear something? How is the compressive load applied on an element? How
Suppose
does it
I
work?
want to, sir, I can
What
say
is
that
tearing? Just explain me. You told that it will get torn if we apply a compressive load. What is tearing?
tearing means
What
that
kind of a load do you apply? You're tearing a paper. What kind of load do you apply? You're cutting a paper. What kind of a load are you applying?
it is shear.
Shear, right?
We are getting shear here,
So
shear
what you
force.
essentially want, if you want to prevent tearing of the membrane, what you essentially
Yes, sir.
want is a good bond, a shear bond between the membrane, the applied waterproofing
Yes, sir.
membrane, and the substrate concrete, not a
Yes, sir.
compressive strength. Compressive strength is required in a bulk of a material, which is expected to take loads, which is expected to take compressive loads.
Yes, sir.
So we don't. I don't think. I mean, we don't want a good compressive strength in a. In fact, you can't even. How do you test the compressive strength of a applied waterproofing membrane? You won't be able to do that, right? It is not required. Why do we require? We just want it to act as a waterproofing membrane. We want it to resist water from getting inside the concrete structure. That's all we want from it, right?
Yes, sir.
Probably there are,
Sir,
I don't remember all the options, but the other options would also be correct. But one of the options you should select is high compressive strength. We don't want that in a waterproofing membrane. I don't know the answers
and
yet, but anyway.
sir, actually the options that were given were the physical parameters like elongation and tear resistance, then surface
Just give
finish.
me a moment. I'll allow you to share your screen
Yes, sir.
so that we'll be able to discuss it at length. Can you
Yes,
check
sir.
now if you can share your screen?
Yes, sir. I'm doing. The option is enabled. I can see that.
Mhm.
Window. So can you see the? Can you see my screen?
Yes, I can see your screen. Yes.
Yes, sir. First of all, I am
Did you
opening.
mail this to the discussion forum?
Yes, sir. I have mailed this to the discussion forum.
I didn't I mean, receive this mail.
Sir,
Anyway,
just a second. I'm opening the SWAYAM portal. Um, my courses. Just a second. Maintenance. This this was of week 8. Waterproofing of concrete quiz. I'm opening the quiz. Yes, sir. The question number 5.
which among the following can be given the list consideration while selecting a waterproofing membrane? Surface finish before installation. Okay, can you show me the first of all? Can you show me? Okay, you have already yeah, the answers are released, right? So the deadline has passed. I'll discuss this. Which among the following can be given the list consideration? Surface finish before installation, right?
Yes, sir.
It needs to be good because um, uh, I mean, for the waterproofing membrane to have a good bond between the substrate concrete and itself, we need to have a good surface finish before installation of this membrane. Second is,
Yes,
so
sir.
we have to consider that, take it into consideration. Elongation and tear resistance of the membranes, as you mentioned, tear resistance has to be there, and therefore the membranes, the polymeric, these are essentially polymeric coatings that are applied on the concrete surfaces, and therefore the elongation and tear resistance needs to be tested and needs to be taken into consideration. The third is compatibility and bond of the membrane. Again, that's also required, right, with the concrete substrate.
Yes, sir.
Otherwise, it won't be apply. It won't be get. It won't have a good bond with the concrete surface, and eventually it will tear off. And the
Yes,
fourth
sir.
is compressive strength of the membrane. We'll come back to that later. And the fifth is overlapping and gluing of the membrane. Yes, that
So now my question is, if I go to a shop for selecting the waterproofing membrane, I know that I will overlap and glue the membranes. It's a constructional practice. But the other properties which other options which are given, they are telling about the property of the material, like the surface
that's what
finish,
is
then tear.
asked in the question. You see, the while selecting a waterproofing membrane, you have to select the material.
Yes.
The fifth statement is related to the application, the process or the application or the workmanship rather, overlapping and
Yes, sir.
gluing of the membranes, right?
Yes, sir.
That is related to the application, and so it can be prevented if you have a good workmanship. But while selecting the material, what needs to be
Yes, sir.
taken into consideration? Does compressive strength need to be taken into consideration? Is it I mean very much required in a surface coating?
That means, sir, the last option is actually the overlapping and gluing of membranes is actually invalid. Among the other four, we have to choose the least one.
Yeah, that is invalid anyway. It is not. You can't. While selecting the waterproofing membrane, how can you ensure that there will be no overlapping or gluing of the membranes? You have to ensure that while the application during the application process, during the you have to tell that to the labor or the worker over there.
Yes, sir. Actually, that was I was thinking while answering this question that this point has no meaning, so it must be given the least consideration.
See,
So
I'll tell you that you have to prepare a mixed design, and you have to prepare a concrete mixed design, and
yes,
there should be no honeycombing at the at the structural element.
yes, sir.
So would you be considering that in your mixed design? Is there a parameter that you can tweak so that you'll be able
No,
to get ahead of this
honeycombing is
honeycombing?
actually the workmanship.
Workmanship, right? So
Yes,
that's
sir.
what is being asked in this way. You have to choose the materials that so that you have to choose the materials in such a way that there will be less segregation, less air voids, and less segregation and bleeding, so that at to some extent you'll be able to control the a probable honeycombing. But again, it has to be related to the workmanship. If there is not sufficient vibration that is being applied, then there will be
Yes,
honeycombing
sir.
in the so even if you have provided a very good concrete mix, you have tested the concrete mix in your laboratory, and you've
Yeah, yeah,
gotten
yeah.
very good results, but there might be so this is related to workmanship. This is not a part of the answer anyway. So that is,
Yes, sir.
yeah.
That means this point should not be considered among the other four. We have to choose the
Yeah,
least.
you can't
Then
consider it
compressive
while
strength.
selecting the material. That's what is being asked.
Yes, sir. And about compressive strength that I was mentioning, if I give a load, it can cause cracking of the membrane. So it in some way it would hamper, but
Why?
it is
Anyway, compressive strength alone. See, if the you won't be able to apply the surface coating at a region which is being exposed to the compressive load. If you're applying it, let's say on a column, right, on a column surface,
yes, sir.
then it will be around the column surface, not on the top and the bottom of the column surface, right?
Yes, sir.
Because
So
you want to
suppose
have a good bond between the beam and the column. So you'll be
yeah,
only applying this around the column surface, and that will again be exposed to tension, not compression.
yes, sir. It
The
will be experiencing tension. Yeah.
right. So you have to have a good bond and a tear resistance rather than a good compression.
Yes, sir. And sir, suppose I apply it on the surface, a horizontal surface like roof, and then place an almirah on it, then it will be getting
So
compressive load.
that is not related to compression. If you are placing a heavy object, or if you're moving a heavy object over it, that is abrasion, not compression. These are very two
Okay.
different properties that you're talking about.
Yes, sir.
It will
Now
be
I
a
Compression
get.
case of
is
punching or
punching, yes,
tearing.
yeah, punching or
Punching in
tearing,
the punching in the vertical direction, tearing in the horizontal direction.
right,
So compressive strength is the least relevant.
right.
Yes, sir. And sir, the mail which I have posted in the forum, I have been answered an hour ago. The answer says that overlapping and gluing of membranes are important to be considered to prevent delamination and having adequate continuity between the waterproofing membranes. But sir, from our discussion, this seems to be an invalid point.
What you can do is you can attend Umesh. He also is a NPTEL. You can attend his session on next Friday, and you can
Okay, sir.
ask your doubt regarding his answer directly to him. it will not be right on my part to answer, defend or argue over his answer, right?
Okay, sir. Then I'll approach to him also.
Oh,
But the answer is compressive strength. Then I get it. Okay, sir.
oh. You can stop
Thank you,
sharing
sir.
your screen. Okay.
Thank you, sir.
Well presented.
Thank you. Thank you, Dr. Suresh.
Okay.
All right. If you have any other questions, then we'll be able to take. Otherwise, you guys are free to leave. The session will go on till 8 p.m. Thank you. All right, we are closing the session for today. We'll be meeting again on next Saturday at 6 p.m. Thank you.